Now we talk about the mean deviation from grouped data. We have seen about the ungrouped, now the grouped data. So we know that the data can be grouped into two ways. First is discrete frequency distribution and continuous frequency distribution. Discrete means any value, corresponding to any value you have some frequencies, and in continuous you will have some interval like 0 to 10 this much, 10 to 20 this much, like this, and there will be no gaps. So let us discuss the method of finding the mean deviation for these types of data. Discrete frequency distribution, we have say n distinct values from x1 to xn, and they have corresponding frequencies as f1 to fn. Now this can be represented like this: mean deviation about mean, and we'll also see mean deviation about median in every case. So we have to find out x bar. X bar is nothing but the mean for a given data, and that is taken by sigma xi fi by sigma fi, and this sigma fi is nothing but the capital N. Capital N is nothing but the sum of the frequency, and this sigma xi fi will be the multiplication of every frequency with the element and then adding it up. So we find the deviation of this xi now, because we have just found the x bar. So we find the deviations of this xi or xi with x bar, like xi minus x bar, and then we find the absolute value of the deviation, of the deviation, and which is the required mean deviation from the mean. So fi, then xi minus x bar, adding it up, and then sigma fi, and we know that this is nothing but the capital N, that is all the number of elements. How about mean deviation about mean? So to find the mean deviation about mean, we need to and we find the median of discrete frequency distribution, and this we have to make an order. So we'll arrange them in the ascending order, and then we'll compute the cumulative frequencies, and then we identify the observation whose cumulative frequency is either equal to or it is just greater than this n by 2, where n of course is the sum of the frequency, and this value should lie in the middle of the data. That is, we'll have the required median, and once we have found the median, we will obtain the mean of the absolute values of the deviation from the median, like this: xi minus m, this is the median, fi into xi minus n, 1 by n. And we'll see this with an example. So we have to find the mean median from the mean of this data. So how we are going to do it, please understand it very carefully. This is xi, this is fi, this is also given, this is also given. So first we'll find out xi fi, that is 2 into 2, that is 4, likewise whole column. Then xi minus x bar, and how we are going to find out this x bar? This is nothing but the sigma fi xi by n, that is this sigma fi xi 300 by capital N, which is our 40. So 300 by 4, 7.5, this will be our x bar. This will be our x bar. And then this x minus x bar we have found out. And now fi xi into x bar means this one multiplied by this one. And this will be, and then taking sigma. Sigma means summation of all these. So that will be 92. 92 by 40 is 2.3. This is how we find it out. Now we have to find the mean deviation about the median. So we have already these members which are already in ascending order. So let us add a row corresponding to cumulative frequency. What cumulative frequency means? You have frequency, just add them, like this frequency 3. So 3 plus 4 will be 7. 7 plus 5 is 12. 12 plus 2 is 14. 14 plus 4 is 18, like this. The last one, 30, should be equal to this sigma f. So now median is actually the mean of the 15th and 16th observation. Why? Because we have 30 members, 30 xi. So the median will be the mean of 15th and 16th observation. And both of these observations, they lie in cumulative frequency, like 18. As you see here, they lie here. Okay. So we'll take the corresponding observation, which is actually 13. So 13 plus 13, that is 15th observation, 16th observation by 2. So 13 plus 13 by 2, that will be our 13. Okay. So what we have got here, median also we have got. Now take all the members and subtract it from median. M means 13. So take xi and subtract it from m. You get this. Now you already have this fi. Multiply this 10 into 3, 30, and say 7 4s are 28. And then you have to take the sigma of this. That will come to 149. So sigma fi is 30 because the cumulative frequency also we have seen. The fi xi minus m, this one, also the summation is 149. Divide 149 by 30. This is your answer, 4.97. Now coming to the frequency distribution, which is continuous. So continuous frequency distribution is actually in this. We know that this has to be divided into or classified into certain class intervals, and this has to be without gaps. There has to be no gap, otherwise this will not be continuous frequency distribution. So it is 0 to 10, 10 to 20, like this. So the example is, say we have 100 students, and these are the number of students who have obtained marks between 0 to 10, say 50 to 60. So let us see the mean deviation about mean, how we are going to find out. So while we are calculating the mean of this continuous frequency, we had made the assumption that the frequency in each class is centered at midpoint. I'll show how this. Just add any of these, means 10 plus 20, and divide by 2. Like this we are going to find out. It is better to take an example. This is example 6. We have to find the mean deviation from the mean of this data. So the marks obtained is 10 to 20 and 20 to 30, all these, and we'll see how we are going to get this. This is marks obtained. Number of students are given. Midpoint is what? 10 plus 20 by 2. 20 plus 30 by 2, like this. So these are the midpoints. So fi xi means this multiplied by this column multiplied by this column. You get fi xi. Then xi minus x bar. X bar you are going to get how? You already had this n, capital N, that is sigma fi 40. You have sigma fi xi, that is 1800, and you also have this x bar as sigma fi xi by n, that is 1800 by 40. So this is 45. Now 45, you have to multiply each 45 by this x bar, okay. What you have found out, the x bar 45 with all the members xi, these members. So 15 minus 45 is 30, like this. 45 minus 15 is 30, and you have got xi minus x bar. Now fi into xi minus x bar. Fi into xi minus x bar means this column multiplied by this whole column, and after this, see that the summation is nothing but the 400, the summation divided by capital N, which is our 40. This is your answer. Then the shortcut method for calculating the mean deviation. See, if we actually see these were small numbers, but there are, in actual scenario, this will be very tedious. This action will be very tedious. So what we can do, we can use the assume mean criteria to actually get rid of the long and cumbersome this computation. For that, what we can do, we can just shift it out. Like if it is 0, say, and if we take assume mean as 60, then this is just a shifting from origin 0. So let us how we can do this. If there is some common factor of all deviations, we can also divide by a common factor, like this. These are the members, so just divide it by 10. See, these minus 10 divided by 10 is minus 1, minus 20 divided by 10 is minus 2, like this. You can divide. So now you have to deal with these numbers, and these numbers are quite easy to handle. So the deviations that I said, and the step deviations, the deviations and step deviation, this will reduce the size of the observation, and we'll see that multiplication will be less. So let us see the new variable, which is denoted by di is equal to xi minus a by h. So a is what? A is the assumed mean. A is the assumed mean. We'll assume a mean, H is actually the common factor. We'll see what it is. Then this X bar is nothing but, if Di is this, X bar will be nothing but assumed mean plus sigma Fi Di. Di is given by this, by capital N into H. Let us take the previous example. Similarly for this, reducing our computation. So A here is 45, H here is 10, right? So marks obtained were this, frequency were this, midpoints means 10 plus 20 by 2. Now this Di is nothing but Xi minus 45 by 10. 45 is our assumed mean, 10 is our this difference of class interval. So now these values, the important thing is that if you add them, it will be 0. So how it becomes so easy. If you add them, it is going to become 0, this column. Then you have Fi Di, this is Di, and you multiply it by Fi. Then Xi minus X bar means all this Xi multiply by the X bar, that is the assumed mean. Using that assumed mean, you have found out the X bar. And how X bar can be computed? See, X bar is computed by A plus sigma Fi Di by capital N into H. So this is 0, we have just found out, and this is H 10, and now this is 40. So this is how we get X bar. Once you got this X bar, X minus X bar, you can find out Fi into Xi minus X bar, right? So the computation becomes very easy. The computation has got very easy, and then you can add it. What you got here now, 1 by n sigma Fi Xi minus X bar, this is what? This was 400. 400 by 40 is 10. So the subdivision method is applied now to compute X bar, and rest things are same. How about median deviation about median? So mean deviation about median. So what you can do here is, let us see with an example now how we can do it. First we have to take the median. This is quite simple. What we are going to do here is, first we have to see the class. So if this median is L, this L is nothing but the lower limit, because now there are two, because there is lower part also, higher part also. So L, whichever value you are choosing or whichever interval you are choosing, L is the lower limit, and this F is the frequency, and then you have this C as the cumulative frequency up till there, and H is the factor, H range, and I'll show you what it is. So median can be computed like this: L plus n by 2 minus C by F into H. This is very important. Now rest things remain same. After finding the median, now the absolute values of the deviation of this median Xi of each class is nothing but Xi minus m. So this median, this mean deviation can be computed like this: Xi minus m, Fi Xi minus m, and this is sigma of 1 by n. So let us take this with an example so that we can understand it better. We have to calculate the mean deviation about median. So this is our class, or these are our classes, and this is our frequency. So how we are going to get it? This is class, this is frequency. 0 to 10, 10 to 20. So first we have to find out the midpoint. So this is the Xi, this is the midpoint. 5, 10, 25 like this. 20 plus 30 by 2, that is 25. This is frequency, so we have to compute the cumulative frequency. 6 plus 7, 13. 13 plus 15, 28. The 28 plus 16, 44. 44 plus 4, 48. This is cumulative frequency. Now this every Xi has to be subtracted with the median, and you know median how to compute. Median is computed like this: the class interval containing this n by 2th, what is n? 50 by 2th, that is 25th item is where? Is between 20 and 30. This is very important, please understand it carefully. The class interval containing n by 2th, that is the 25th item, is 20 to 30. 20 to 30, that is why we have taken this 25th which lies between 20 and 30. So the 20 to 30 is the median class. So lower limit will be 20, this L will be 20. Cumulative frequency, let us see what cumulative frequency it has. It has cumulative frequency as 13. So 13 will be the cumulative frequency will be 15. H, the interval is 10, and capital N is nothing but the sigma f, which is our 50. Okay, now you just place it, you get the median, and now you have got the median, that is 28. You can subtract every element with this 28 and you get this line, and multiply this with fi minus median, you get 508 if you add them up. So this is nothing but 508 by 50, that is 10.16. So this was about statistics. We'll take a few more of these. Till then, thank you so much. Take care of yourself.